All right. Good evening, everyone. Welcome to the class on this training program. This training is brought to you by REnT, Royal Grant Engineering Trainings Limited, in collaboration with Nigerian Society of Engineers, Abeakuta branch, NSA Abeakuta branch. So this is the last training course for this program, which is Ansys FEA. Let me minimize it so that you guys can see me clearly. Okay, so this course is Ansys rather, but we'll be focusing on just FEA, which is a finite element analysis. So this is the last course for this program, and today is our first class. So we are supposed to have our class yesterday, but due to some emergency, some reasons, some personal reasons, I was not available for the class. So I really apologize for that. So we'll be having our first class today, and tomorrow, probably tomorrow, we'll be having the second class. Then we'll round up on Friday. All right. So my name is Ugu Henry Christopher. I will be your instructor, your training instructor for Ansys software in this program. I have years of experience as a training instructor. I'm also a mechanical engineer and also a computer-aided engineering designer. Okay, I've been using Ansys for a very long time and also in the industry. So our topic for today is Ansys software. Okay, Ansys is a software. Of course, this is what we are here to learn today. So, but let's start by defining what Ansys means. So let's try and understand what it's all about, so that when we start using the software, we'll have the foundational knowledge of it, or we'll understand the basics, the principle guiding the Ansys software. Okay, so by Google definition, Ansys is a comprehensive engineering simulation software suite used to simulate and analyze complex design before they are physically built. Okay, take note of this keyword here: simulate and analyze complex design before they are physically built. Okay, used to simulate and analyze complex design before they are physically built. So take note of this line. Okay, you use Ansys to carry out your analysis and simulation before they are built. You do a study, a deep study on the feasibility. You use it to do a study on the feasibility, the workability of your designs before you go ahead and manufacture it. That's what they mean by physically built. And it's by doing that, you are helping engineers to optimize design, reduce cost, and improve product quality and reliability. Okay, most of us in engineering know that it's common practice that before you go ahead and build something, you need to test it. Or rather, after building something, probably a prototype, you need to test them for the workability of that material. You need to test the principle of operation of that your prototype before you go ahead and commercialize it and start building commercial quantities to know if the design will actually work or if it will fail in practice. Okay, so after designing and producing something, you end up having to test that product before you send it into the market or before you start producing commercial quantities. That is how it has always been done from time immemorial. Okay, so but these are with the invention in engineering, the advancement in engineering, softwares like started springing on. One of those softwares are Ansys. Okay, so rather than building a physical product and testing, it will cost you more money to build something that is tangible and test it. If it fails, you go back and build again. You know how the design process is. When you test, it fails, you have to go back and iterate the process. Keep on iterating till you get the desired result. So if you want to build a car, for instance, now, and you are just building a car for the first time. You are building a car for the first time. Well, let's say those of us in Nigerian engineers there is no firm that builds aeroplane in Nigeria here, or you are building something like a jet engine, a part of an aeroplane, such as the jet engine, that's the propeller, and we are trying to build something like that in Nigeria. Of course, we don't have the prototype or the variables, the things we need to build it here. We don't have the knowledge here. We have to design everything from afresh, even with the limited, or probably with the limited information we can find on the internet. Okay, we can try and say, okay, let us build our own prototype. Let us build our own jet engine for aeroplanes, and we go ahead and start building. You'll find out that your first product will be feasible. It will not be feasible. You might not. It will not be working perfectly. You have to go back and improve on it, test it over and over again. When you test, it doesn't work, you go and do the correction. When you fix that correction, you find out that there is another problem that you need to go and do. Probably the material cannot withstand afterburn or high temperature. You now have to go and work on the material again and select a suitable material. So all these iterations that you are going to do, it's going to cost you a lot of money, because all those materials you need to build something like that, a jet engine. You have to source it from the market. You have to source those raw materials from the market. Even your time and your energy you are putting in, those that are working with you, you have to pay them. So all those things cost money. Okay, and it makes it more and more difficult. So, but with softwares like Ansys, other engineering softwares like analysis software, you can do all those iterations, testing, validation, checking for the structural integrity, the material composition, all those things. You can do them in the software without having to spend money and be reproducing those things in real life. Okay, so if we in Nigeria now are going to do like 10 up to 10 tests on a product such as that jet engine, we are going to do up to 10 tests before we get the final result, which will be feasible, which will be workable, which will be able to function properly. Okay, you know the amount of money we are going to spend. But if we have using a software such as Ansys, we can do those 10 tests in the Ansys software without having to spend more on raw materials. You do those tests on the Ansys software. You have the capability to carry out most kind of analysis that you need. Okay, most analysis you need, you Ansys have that capability, so you can do even if material selection, material composition, then you go over to the structural integrity analysis, the thermal analysis to check if the material, if the propellers will be able to withstand the heat and pressure. You also check the fluid analysis, if the flow of air along the material will not cause any long-term damage. Okay, so you can do all those things in the Ansys software and then get the final result, which you now use to produce your and which you now use to produce your product in this example, which is the jet engine. So you don't have to spend. So that's why they say it helps engineer optimize design, reduce cost. This is very important. This cost reduction. Okay, Ansys and most engineering analysis software help you reduce costs. Those costs that you will spend, those costs that you are going to spend, those money you spend trying to produce those things, test those products to get your desired results. Ansys eliminates those costs for you and improve product quality and reliability. That's the major advantage of this Ansys software and most engineering software. Okay, so it can also be defined as a suite of computer-aided engineering. Okay, engineering software used for finite element analysis. Finite element analysis, which is the branch of analysis that we'll be focusing on in this training program. Finite element analysis, then you have the computational fluid dynamics. Like I told you, that Ansys comprises of several different or most kind of analysis that you'll be needing in engineering. Ansys comprising at least 90% of it. Okay, thermal analysis also, you can also do thermal analysis in Ansys. Computational fluid dynamics is to carry out an analysis on the fluid flow of the flow of a fluid or an air over a structural body and how it affects it. Okay, that's your computational fluid analysis. Okay, then you also have the thermal analysis, that is the analysis on thermal. You also have your electromagnetic field simulation, mostly used by electrical engineers to simulate thermal.
Let go.
Sorry, someone is saying
No.
something. I can't hear you. Please speak louder. Hope you guys can hear me, please. Let me confirm. Can you guys hear me?
Yes.
You're audible. Please, you should mute
Okay.
himself.
and allow you to talk. Thank you.
So let me continue then. All right, so I was mentioning the kind of analysis you can do in Ansys. Yes, Ansys comprises of all these analysis: finite element analysis, computational fluid dynamics, which is also the analysis of fluid flows. You have your thermal analysis, which is the temperature distribution, heat flux, and the result. Then you have your electromagnetic field simulation, your multiphysics. Multiphysics coupling is when you want to couple two or more analysis, like your finite element and your CFD, or finite element and thermal, or your finite element and electromagnetic field simulation. That is when you are carrying out simulation, electrical simulation on semiconductors, electrical components, your diodes, and the rest. Okay, so these are just a grouping of a group of analysis. Finite element analysis is a group on its own. Computational fluid dynamics is a group on its own. Thermal analysis is also a group. The same thing with electromagnetic field analysis and multi-field. So they are all grouped on their own. So inside finite element, you have other analysis under it. Okay, that's what this thing entails. Okay, so Ansys comprises of all this analysis. So I think it covers most branch of engineering, from mechanical to electrical to civil to petroleum. Most of your analysis can be done on the Ansys software. Right? So, like I said, you can use Ansys for structural analysis on a bridge structure. This is like a simple design of a bridge structure. You can carry out a structural analysis on a bridge, like for civil engineers. You can also do thermal analysis to show the temperature distribution along the body or of a system or a solid. You can also carry out a fluid flow analysis. This image signifies the flow of air over a moving body, an aerodynamic vehicle. You can see the air flowing over an aerodynamic vehicle. That is this is all about. This is comprises the computational fluid dynamics. That is the flow of air over a body. Okay, so the types of analysis. Please mute your mic. Someone is saying something. Please mute your mic. Mr. Christopher, please, if you can mute that person, that the mic is on. Someone's mic is on, please. It doesn't interfere with the class. Prince Will, mute your mic. I don't have administrator. Prince Will. I think I can mute now. All right, good. Let's proceed. Okay. So types of analysis. We have different kinds of analysis. We have our structural analysis. We have your thermal analysis. You have your structural, that is under your finite element analysis. That's also this structural analysis under your finite element analysis, which is FEA, which is what we'll be focusing on in today's class or in this training. This is FEA. So finite element analysis. Then you have your thermal analysis. You have your computational fluid dynamics. This is also known as CFD. Okay. So you have your electromagnetic simulation for mostly electrical engineers. You have your multiphysics simulation where you are coupling more than one analysis. You want to do a thermal analysis and a structural analysis together. That is known as multiphysics simulation. Okay. These are some of the analysis we have in Ansys. Okay, there are so many of them, though these are just the few or the basics that I wanted us to discuss today. Okay, then for this training, we focused mainly on finite element analysis. Okay, so like I told you, finite element analysis, this analysis up here is like an umbrella of analysis. So under the finite element analysis, you have lots of analysis under them. You have example, so many analysis under them. Like in our finite element analysis, we have the static structural analysis that we use to. For static structural analysis, we use it to analyze use it for steady non-time varying loads. That is when we use it to carry out the analysis when the load does not change with time. That's what it means. That is static structural. The load is static, is not changing. The load that you are applying, the boundary conditions you are applying on a body, on a structure is steady, is static, it doesn't change over time. That's what we use static structural analysis for. Okay, you also have the dynamic structural analysis. For dynamic is the opposite of static. For dynamic is the load conditions on that structure changes with time. For instance, on a bridge, okay, you have a bridge structure and cars are moving along that bridge. So at every spot in that bridge, the load condition at that spot changes because when a car moves to this, Sophia, are you trying to say something? I think Sophia just raised her hand. Please don't, if you want to ask a question, please, you can unmute your mic and ask. I will attend to you. Okay, let's proceed. Okay. All right. So as I was saying, I was explaining dynamic structural analysis. I'm saying it's the opposite of static structural, meaning that the load condition on that structure changes with time. Okay. So if you have, let's say, a table, for instance, and that your table, you have something like a flower vase on that table, which is you are not moving it anytime. Probably that flower vase will be on that table or on that shelf, a shelf that is attached to a wall, and you place the flower vase there. The flower vase might be in that position for like 3-4 months straight without you changing it, okay, without you moving it from there. So that if you're carrying out an analysis on that shelf that you place that flower vase on, that you are going to carry out a static structural because the load, which is the weight of that flower vase on that shelf, which is on the wall, doesn't change with time. Okay, it doesn't change. It's static. It doesn't change. It's steady. So, but if you have a structure such as your a bridge structure, for instance, now, and cars are moving along that bridge, okay, let's say at every spot, at every section of that bridge, the load condition changes because at a time the car will move over there. Okay, the car will move to that spot and move away from because it's moving. It's not static. It's not standing at a spot. Okay, why it's moving away? The first one might be a car, the second one might be a bicycle, the third one might be a lorry. Okay, so the load condition changes with time. So whenever you are doing an analysis on a structure like a bridge structure, it's going to be a dynamic structural analysis because the load conditions, that is the load that is being applied on that structure changes with time. Then you have your modal analysis that you use to determine the natural frequencies and mode shape of your structure. Okay, we normally use it to determine the vibration behavior of a body. Okay, that's what we normally use this modal analysis for. Then you have your thermal analysis, which, like I explained before, it predicts the temperature variation or the temperature distribution on a system and how this temperature changes with time. Okay, so under thermal, you can have steady state thermal and transient state thermal, meaning that the thermal load changes with time or your thermal result changes with time. Or and some that is for transient, it changes with time, but for steady, your temperature distribution is constant. Okay, if you are using the cooking gas, for instance, now you are using a cooking gas and you turn on your gas to a particular level, let's say turn it to level 3, okay, and it starts cooking. Okay, you notice that the temperature from that fire burns at a constant rate. So the temperature addition to that your pot now is constant, so it's steady, it's not changing with time. The temperature, the rate at which that fire is burning from your gas is constant, it doesn't change with time. So if you want to do that kind of analysis, you're going to use a steady state thermal analysis. But if it changes in a situation where it changes with time, let's say like a brake pad system, okay, you're going to use the transient state thermal analysis. So you have your nonlinear analysis, which is kind of an elaboration of some of these analyses used for doing complex deformations, complex behavior such as large deformation, material plasticity, and contact interaction. These are for much more complex analysis. The same thing with these three. These three are the simple ones we have. These four here are the simple ones we have, the basic ones we have. Then this one for advanced cases. Okay, buckling analysis is to determine if a structure will buckle under a constant loading condition, under any loading condition. Okay, if it will buckle. For instance, your mast, your telecom mast. Okay, you know that it's a very slim, tall structure. So it's being you have some loading condition from the wind, from the weight of those things attached to the mast. So if let's say rain is falling and there is a large wind or something, I know whether we have weather changes, so they do affect the structural integrity of that mast. So you can do an analysis to determine if those load condition will make it work. Okay, who is this? Let's see. Please speak louder. I can't hear you. Treasure.
Sorry, sir.
Okay. All right. Please, if you have any question, if you have any question, you can drop it in the chat box. I will attend to you. Okay, from time to time. All right. Let's proceed. So I was saying, I'll just explain buckling analysis. If you want to do analysis to determine if the load on a body will make that body to buckle, okay, like the word implies, buckling. If the load will make it to buckle, that's buckling analysis. Then you have your explicit dynamic analysis. It's also an elaboration of some of these ones, okay? So for explicit, you simulate highly transient events, okay? For example, if you want to do a crash test, like if you want to determine the stress on a body, on a car, if it crashes on another car or if it crashes to a wall. So that is a very high transient event. Okay, the parameters changes with time and still the strain, the stress will be very, very high. So you use the explicit dynamic analysis rather than using the static or transient. Rather than using the static analysis or dynamic structural analysis, we use the explicit dynamic analysis, okay? Because the parameters of our result are very high, such as a car running on high speed end up crashing with another car, or you are holding your phone. Okay, imagine holding your phone and you are walking, you are doing something, all of a sudden it falls from your hand or from a height and crashes on the floor. So if you want to carry out those type of analysis like a crash test analysis, you use your explicit dynamic analysis. So these are some of the examples of analysis we have under finite element analysis, but we don't have, I don't think we can cover all of this in this training program, because this training program is just 3 days. So we'll try as much as we can. Like today now, we'll be doing mostly the overview and software navigation. Okay, so we won't have enough time to cover most of these things. But in our advanced classes, we'll be going into depth. Okay, we'll be going into depth and talking about them. There are so many other analysis. You also have the simple harmonic analysis, the random vibration analysis. There are several analyses that we have here, but these are just some of them, or the most common of them. So if you are in any engineering field and you find yourself doing any finite element analysis, you will likely run into any of these. Okay, most or else you are working in a firm and you guys are doing some advanced stuff. That's when you now have to touch on the other aspects. Okay. So that's all about finite element, the examples of analysis under finite element analysis. Then careers as a Ansys professional. Okay, so you knowing how to use Ansys might give you an edge in the industry. Not just an edge, you can even seek for a job position on just this software alone. Okay, so I myself also, because I'm telling you from experience, I'm working in the industry. Some of you are professionals. I believe some of you are professionals. You're already working in the industry, so you know these things I'm saying. Okay, so while those of you that are students, okay, so this is not like I'm saying something or I'm pushing, I'm preaching to you. This is actually the reality of things. Okay, so with just learning this software, like there was a time I applied for a role as a CFD engineer, okay, and by CFD engineer. Yeah, this is just a branch of analysis. Remember, I told you in our, where's my mouse? Okay, remember I told you that CFD is just a part of Ansys. It's just a part of Ansys. CFD, and please let me make this correction. This analysis, such as structural analysis, thermal analysis, computational fluid dynamics, are not just found in Ansys alone. No. Okay, these are kind of analysis that you carry out on an engineering bodies. These are analysis that you carry out in the engineering field. Okay, but Ansys is a software that enables you to do this analysis. Okay, so when someone say computational fluid dynamics, you are looking for someone that does CFD. They are not necessarily saying someone that uses, and they might say, okay, they might want someone that uses those CFD, but with another software that is similar to this or that is different from this. Okay, so CFD analysis is a fluid flow analysis of any fluid flow analysis at all. Whether you are doing it with your hand, or you are using your hand to do the calculation, or you are using another software to do it, or you are doing physical experimentation. They are all CFD analysis. But Ansys is a software that was developed that will enable you to do the CFD analysis on your computer without having to carry out a physical experimentation. Okay, so I told you I think I have done a lot of jobs on this CFD analysis. There was even a time I interviewed for a role on this. They were looking for a CFD engineer, just CFD, just one aspect of engineering analysis. And they said they were looking for someone that uses Ansys specifically to do CFD engineering. I've also seen those that does finite element engineer. Just this one. This is broad. You might be looking at it as something that is simple or very common. Or probably those of you in university, you are probably using it to do small, simple analysis, simple basic analysis. But they are actually very, very broad, and they cover a wide range of engineering field. Okay, so you can, by learning Ansys and getting certified in it, you can seek for jobs in these various fields. Okay, like rather than using and this knowledge give you an advantage. That's why we in Royal Grand always made it our priority to make sure we provide these skills to Nigerian engineers. Okay, so it's very important. It can give you an advantage. Let's say you are a mechanical engineer, or you are an electrical engineer, or you're a civil engineer. You graduate with just your certificate. The only job you can apply for is a job title that has that generic role: civil engineer, or mechanical engineer, or electrical engineer. But if you had other skills, other engineering or mechanical engineering related skills to it, you can apply for those jobs. So there are some jobs that you will see, they might not necessarily need a mechanical engineer. You see stuff like CFD engineer. Like I told you, I did one of the CFD engineer. You also see CAD engineer, computer aided design engineer. So you can apply for those jobs. So it gives you an advantage rather than looking for those generic mechanical engineering role where they will make you graduate trainee, or where they will take you as entry level, which is even difficult because you're not the only one applying as a mechanical engineer. You're not the only one with certificate, mechanical engineering or engineering certificate. You're not the only one. But you learning the skills will give you an edge to separate you from the rest. Okay, that's the major advantage of acquiring these skills. So you can apply as a design and simulation engineer, FEA engineer, CFD engineer, and so on and so forth. You can also be a consultant too. Okay, so it gives you that an advantage. And again, when you are applying for jobs, even those generic engineering roles, those mechanical, those engineering professionals here that are already working can attest to this, that some of the engineering positions, when you are applying for them, you find out that even if they are generic engineering positions, like chemical engineers or mechanical engineering positions, when you look at the roles and responsibility or what they expect from you, you find out that they are listing some of this software as a criteria, as an eligibility criteria. So when you look at that eligibility criteria section, they'll be listing something like you must have the knowledge of a CAD software, either SolidWorks or Fusion or AutoCAD. You should have a knowledge of an analysis software, either Ansys or Aspen Plus for chemical engineers, or they will list another one, Puta Structure for civil engineers. Stuff like that. It's part of the distance. So those who are working can know what I'm saying, talking about. So those of you in who are still in school or a recent graduate, it's very, very important you acquire these skills. It will give you a huge advantage in the industry. Okay, so these are some of the careers you can pursue as just an Ansys professional. Okay, as just someone that knows how to use Ansys. These are some of the careers you can pursue. I just listed a few. There are so many of them, so you can even do more research on that. So industries where Ansys skills are applied. Ansys skills are applied. These are just few of them. Ansys skills are applied on almost in every industry. I think there was a documentary they did on Ansys where they were discussing about industry or companies that uses their products for their operations. Okay, so they were listing several industries, starting from the engineering to aerospace. Even NASA uses Ansys, and NASA uses Ansys. And they listed NASA, so several. I think they listed Boeing or something. All these companies that produce aeroplanes. They listed even hospitals to startups, several companies, waste management firms, like different in different industries. It was as if it covers all industries, including construction. Okay, they use Ansys as a software. So imagine you as a student now, you know how to use Ansys, and you graduate, you are looking for a job. It gives you a huge advantage. When you are talking, or when engineers are talking, you know what you are saying. You can come out with confidence that you know how to do this. You know when you go for a job interview and as a mechanical or as any engineering discipline you studied, they know you have a certificate. Okay, you graduated first class. Tell us what you know. What can you do? You can come out and with confidence say, I know how to use this. I know how to use Ansys to do this, and this. Okay, they know that, oh, this guy is special. He knows what he or she is doing. Okay, so that's the advantages of learning of this Ansys software. All right, so our time is fast spent. I think this class should end by or I will end my teaching by 9:30, so that you have time for your questions. Okay, all right, let's proceed. Before we go into the software, does anyone have any question? Does anyone have any question? Please, if you have any question, drop it on the. Okay, I'm seeing some. Okay, someone asked a question. Jonathan Oyewole asked, which Ansys app is the main workspace app? Okay, I will explain that as we move into the software. I'm going to explain. Is there any other question? As in my next explanation will answer this question. Okay, Jonathan. So please be patient with me. Any other question? You can unmute your mic and ask. So if you have any question, please don't be scared to ask questions. This is why we are here. We are here to learn. So please ask your questions.
Good evening, sir.
Good evening.
Please, in the pre-recorded version, you didn't explain how to put the model in the software because I was trying it and I was confused.
Okay, in the video I sent earlier.
Yes,
Okay,
sir.
okay. Yeah, sorry. I apologize about that. I will correct that. I think that video I didn't even edit it properly. I cut out that part. So I'll explain that. So any other question before we proceed? Someone is saying something. All right, let's proceed. There's no question now. All right. First of all is okay, so the first thing is Ansys introduction to Ansys software. So first thing is to open up my Ansys software. Okay, so this is the Ansys workbench. Okay, workbench is like the canvas of your Ansys of software. So Ansys workbench is the major. To answer your question, Jonathan, Ansys workbench is the major software, is the main software or the main workspace that you need to run any analysis. So from Ansys Workbench, you can set up any analysis that you want. If you want to do the structural, if you want to do TEMA, you want to do CFD, if you want to do electric analysis, you can do everything here in Ansys. So you can do it from this Ansys Workbench. But I also want to let you know that even though you don't want to go through this Ansys Workbench, you can go open those app directly, because when you install your app, you go to your start menu here, you can search for your analysis, say Ansys now, Ansys, and search for Ansys. Okay, you see your Ansys software, or your Ansys software here, or you come to your start this is the start button, right? The start menu. Then you see your Ansys folder here. You can click on it to open up the drop-down menu. Then you can access any of the Ansys software that you want. You have your space claim, you have your mechanical, you have your workbench here. You can open any one individually from this place. Okay, you can open any of them individually for this place. Okay, you have your Ansys Discovery, your Chemken, but you can do that, all right. You can do that, all right. But if you want to manage your analysis, let's say you are working on more than one analysis, and you want to have control over how you or you want to couple one or two analyses together, you have to go through this Ansys workbench. So I will always advise you that anytime you are doing any analysis, always go through the Ansys workbench. It will be very, very much more easier and understandable for you. Okay, so to make your work easier and much more streamlined, always go through the Ansys workbench. Okay, so because if you are going through this one now, you are going through this process, you have to be doing everything individually. Okay, when you are done designing here, you will close it. Now go back, you close it, save it, and go back, open another software and open it in that software to do another thing. Then when you are done there, you close it again, come back. You know, all those back and forth. It's not productive. Okay, so the reason they brought Ansys for you is for you to be able to carry out all the analysis you want to do, everything in one interface. Okay, that's why they brought this Ansys software. That's why they brought this Ansys software for. So rather than doing those back and forth, you can just do everything here. All right. So it's advisable to do it from the Ansys workbench. So this is your Ansys workbench. So this is your Ansys workbench. So if you have any question, be dropping them in the chat. I will attend to them one after the other. So this is your Ansys workbench. You have at the top, at the left-hand side here, you have your toolbox. Okay, where you have different analysis systems. You have several systems here. This is the most important part. All right. This is the most important part here. You can see analysis system. If I should minimize this box here, if I should minimize this box here, okay. If I should minimize this box here, you can see I have our analysis system. You have your component system. You have your constant design exploration, optics lang, and optics lang distribution. So these ones are advanced ones. So your major focus is on the analysis system. The component system is like a breakdown of this analysis system. So for instance, if you see my static structurer, under your analysis, you find your static structurer there. Okay, this is static structural analysis. That is your analysis system. You have the software for your engineering data. You have a component for geometry. You have a component for model set or every other thing. Okay, but for the component system now, you see breakdown. You can see you have your engineering data here. You have your geometry here, which is this. Then you have your model, your mesh, and every other thing. So component system is a breakdown of analysis system. So but your major focus should be in this analysis system. Okay. So we have several analyses, like I told you, those ones we listed there in that slide are not every. You can see how many analyses we have here. You can see how many they are here. You can see there are so many analyses. Like I told you, you have your random vibration response spectrum. All these ones are still finite element analysis, but they are advanced ones. You have your LS Dyna, even those that explicit dynamic analysis that I explained to you, which is under finite element. You can do it with LS Dyna. LS Dyna is like the advanced software that we use for carrying out all those crash test analysis. Okay, I think it's Mercedes. Okay, no, Formula One. Yes, Mercedes Formula One. They use this LS Dyna, this ANSYS LS Dyna to do their crash test analysis. So when they are done designing their car, they will use LS Dyna to crash it to know whenever a car crashes, how it will affect the integrity or the chassis of the automobile and how it affects the driver itself. Okay, so you can see companies use this ANSYS software. Okay, but I want to also iterate that ANSYS is not the only analysis software out there. There are so many. Okay, but ANSYS is the most common one that I know that is common in the industry. Okay, so we have several analysis systems, but we are going to start with just one, which is the static structural analysis. So how do you attach a static structural analysis? I should scroll down here to static structural. You can see, scroll down to, if you want to start up or launch a static structural analysis, you just go to your analysis system. Under the analysis system, you scroll down to static structural. Then left click on it. When you left click and hold, you drag it out and place it in the canvas, but not anywhere. You have to place it in an open box. You can see whenever you click and drag into the canvas, an open box, the canvas will open up a box for you. Right? You place it inside, or you can place it, either you place it in an empty box or you place it on top an existing one. That's why I say it helps you to Ansys workbench help you to couple more than one analysis. So you can do structural analysis, then attach a thermal analysis to it. Okay, you can do structural analysis and attach a thermal analysis to it. Like for instance, now we have a static structural analysis. We do our analysis, and I want to attach a thermal to it. That is what we also know as multi-physics coupling. You can go to steady state thermal. Under the static structure, you have the steady state thermal, which is the constant thermal. Okay, you can click and drag it into the project schematic. Okay, you can see these two will be highlighted, telling you that you can couple on top of these two, or you can place it as a standalone in an empty box. So if I want to couple it with this one, I'll just drag it and drop. Okay, I'll just drop it on an existing. You can see it has been coupled. So any result or values I get from this static structure will be transferred to the steady state thermal. So we now use this steady state thermal analysis. Now we now use the values you got from your structural. Let's say the stress value you got from this structural, the deformation. I'll now use it to calculate and check how it affects the temperature distribution of that body. Okay, so this is how one of the ways you couple analysis. You can also leave it as a standalone. You can drag it and drop it as standalone. Okay, you can drag and drop as a standalone. And if you have your fluid flow, you can see fluid flow, also known as fluent. You have your space and fluent for CFD analysis, which is your computational fluid dynamic analysis. Okay, to do fluid, to simulate the flow of fluid over a body. Okay, so I'm going to open up just one of them. We launch my. We are going to launch our this thing. And first of all, the first step, when you look closely at this, let me explain the basics of this analysis. Let's focus on this first one, our static structural analysis. Okay, the first thing there is the engineering data. Engineering data is where you select your materials that you want to use for the analysis. Let's say the material is steel or aluminum or wood or cast iron, any material. It might not be iron, it can be plastic, any material. This is where you select the material. That is the engineering data. Then you have the geometry, where you insert your geometry. You want to insert a geometry for the model. You want to import a geometry for that analysis. Okay, just for anyone you want to use or you want to open up, just left click on it. When you left click, you have the option to import, to replace, or to edit. Okay, there are 3 softwares in Ansys that you can use to create or modify your models or geometry that you'll be using for analysis. One of them is Ansys Discovery. The second one is Ansys Space Claim. The third one is Design Modeler. So these 3 are known as CAD softwares. Okay, there are CAD software that are embedded inside Ansys that you can use to create models or modify your model. You can see now it's telling us edit because a model has been selected already, and you have the option to replace it. Okay, to replace, you can decide to replace. Okay, but if it wasn't selected, like in this case, I left click here, you can see no model has been selected here. That's why we have this check mark button, this question mark button. You can see new discovery. It's no longer edit, it's now new, telling you that you want to create. So if I should click on any of these 3 button here, you are trying to tell the software that you are trying to create a new model. So it will not direct you to that software where you will now design a new model for your analysis, or you will now import. You also have the option to import. Okay, since this thing is empty, so there's nothing there, you cannot replace it. So you have to import new one. So you can click on this. Let's say you want to select this model and click, or you can click on browse to select from your file explorer. We have the option to select from your file explorer. Okay, but I'm going to click cancel. So, or you can import from here. Okay, sorry, this is copy, so I have to select from the original. You can import from here and say, I want to select this and say, click on, left click on it. If you select it, now you can see that we have a check mark button. Okay, then the third one is the model. The third one is the model, which will open up the Ansys. This model is where you do your meshing. Okay, this model is where you do your meshing and you're setting up your boundary conditions. Okay, you can also view your results and every solve the analysis. Okay, for static structural analysis, you can do everything in one software, which is the Ansys mechanical software. Okay, but there are some analysis like the fluid flow. Okay, this fluid flow analysis where you have to create the model in another software, you mesh it in the Fluent software. Then for your results, to view your results, you have to use another software, like say a CFD post to view your result, okay? So whenever you are using Fluent, you might end up using up to 3 softwares, which is embedded in Ansys too, okay? But in static structural, you have to use one software is enough. Okay, so when you let's click on model to open up the model, it will open up our Ansys mechanical. So whenever you are doing static structural or most of finite element analysis, you are going to be ending up using mechanical, Ansys mechanical. Okay, this Ansys mechanical software. So our Ansys, I just launched our Ansys mechanical software. Yes, yes. Jonathan, yes, we'll be taking attendance. Let me post the attendance.
I'm doing okay.
Mute your mic. Samad, mute your mic.
But I have not been saying.
Samad, please mute your mic. Please give me a few minutes. Let me post the attendance link. Thank you for reminding me. So, Sophia, you can go ahead and ask your question.
This CAD file that you are using, is it like a step file? Because I don't think the normal file can work with Ansys.
Come again.
The file, like the CAD file you are using, did you make it a step
The
file
CAD
or is it a
file?
normal CAD file?
Yes, it's a step file. Yeah,
Yes,
it's a step file.
the geometry.
Yes, it is.
So how do we
Yes.
make it?
Okay, so that's not a problem. I will explain that. First of all, Ansys accept any CAD file. Just hold on. Okay, I just dropped the attendance in the chat. I've dropped the attendance in the chat box, so you can fill your attendance. Yeah, the course code is Ansys Day 1. Please, if you have any issue with the attendance, let me know. For Sophia, your question, how do you convert to a step file? You can only do that in your CAD software. Okay, when you want to save, you can save. You have the option to save as step. You have the option to save as any format you want. Whenever you want to save your file in your CAD software, either Fusion or even in this Ansys software. Ansys have CAD, like I explained. Ansys have CAD software here. You have your design modeler. You have your You have your discovery, you have your space clean, you have your design modeler. So even if you're using these ones to design and you are done designing, you want to save it, you can have the option to save as a space claim file, or as a step file, or as a fusion file, or as a SolidWorks file. So most CAD softwares now, you can save and open it as any of them. Okay, so this one was a step file. So I can open up a fusion file here in Ansys too. So you have the option to do that. You can open a SolidWorks file here in Ansys. You can open an inventor file here in Ansys. So you have the option to do any one you want. I think most CAD softwares now are very, very flexible. So there isn't much restriction on what file you can import or not. Okay, Ansys don't even if those CAD softwares are doing that. I know Fusion doesn't do that. You can open any CAD software in Fusion. Okay, you can also do that in Fusion. In Ansys here, you can open any CAD software in Ansys. It doesn't necessarily have to be a step file. But if you're having any challenge with probably opening the file, so I will advise you, step file are the general accepted file format for any engineering software. Step file are the generally accepted one. Okay, so they are general. So if you want to save it in case you're having problem importing any file to any software, try and save it as a step file. So just under the save section, then change the file format to step.step.stp or step format. You only see it there. Most CAD software gives you that flexibility. Okay, so let's proceed. So now, if you have more questions, you can drop in the chat box. Okay, our time is almost. This guy, okay, I've answered Jonathan's question. So even if we can't finish today, tomorrow we'll continue from where we stopped. Okay, so for today we only did introduction, so there will be no assignments for today. But rest assured, assignments will have to be. You have to make sure assignments will be available tomorrow after tomorrow's class. I'll make sure there's assignment. Okay, so prepare your mind. And also, this class is being recorded. This session now is being recorded, so we'll make it available after the class or probably tomorrow morning. Okay, so our Ansys Mechanica is now open. So this is the Ansys Mechanica interface. This is your Ansys Mechanica interface. So at the top here, you have your toolbars. You have your toolbar. At the top here, you have your toolbar, and you can switch between section. This is the home, this is the model, this is the display. Okay, these are tools that you use to carry out your analysis. At the top, at the left here, you have your project schematic. Okay, so while at the bottom, just below it, anything you open here will be reflected here. So if I should click, these are like the detailed form of anything that has been selected. Like for instance, I select under geometry, I select our model, that our step file. I left click on it to highlight it. You can see this. You now see details of that step file, Ansys tutorial model for the 2D analysis, which is what we have here. So this is the details of anything you select here. That's what you have on there. So currently it has no thickness, so I'm going to assign a thickness and say 1 millimeter. Enter. Okay, so you now have your check mark. So before you do any analysis, make sure everything has a check mark, except the analysis setting. Anything above this should have a check mark. Everything from this mesh upward should have, sorry, let me correct that. From mesh upward should have a check mark before you can do any analysis. While anything below this must have a thunder button. Okay, so you now currently we have a question mark here. We have a question mark here telling us that all parameters are not complete, so we cannot solve this analysis. So whenever you want to solve analysis, for you to know that your analysis is ready to solve, everything from the mesh above, we have a check mark. Currently, the mesh is I think is a thunder button now. Okay, let me zoom in so that you see it properly. You can see the mesh now is a thunder button. It has to be a check mark for you have to generate the mesh. That is, it has to be a check mark for you to run the analysis. While below the mesh, that is for the analysis setting, which is the static structural, and the solutions have to be this thunder button. This thunder button that you have here has to be here and here. This question mark will have to disappear for you to carry out any analysis. So if you still have question mark here, you cannot solve this analysis. This solve button here, you cannot use it to solve the analysis. If you have a thunder button on the mesh, you can also not, you might be able to, because if you have thunder button all through, even on the mesh, and you go ahead and solve, sometimes, depending on the settings of your Ansys, Ansys will first of all create the mesh, generate the mesh, before it will now go ahead and solve this, okay? But depending on the settings. All right, so we've assigned the thickness to our model. So you can also assign the material property that you want, but to the default material. So you can see them under the material, scroll down to material in your details. Scroll down to material, you have the assignment, material assignment. It's always by default, it's always set to structural steel. So you can always, if you can click on this arrow here to change it, you wait for it to load. But currently, we want to use the default material. So in upcoming examples in our tomorrow class, we'll try out the use of other materials also. So the next is generate mesh. Okay. So under the mesh section, you see anytime I click on anything, the details of that settings will open. Okay, currently I'm on mesh settings. Initially I was at geometry settings. Now I'm on mesh. Let's click on it to highlight the details here. The element size. If you should generate this, you can see this. Just pay attention as I hover this mouse around this body. You can see this circle that is close to the mouse. It's telling you the size of your mesh element. Okay. It's telling you the size of your mesh element. So if I should go ahead and right click on mesh and say generate mesh, it's going to generate a mesh that is relative to that size on this body. Just watch. Okay, you can see it now. You can see how big the mesh is. But if I should reduce the mesh element size here, now currently it's 124 mm, and I change it to 10 mm. And I click enter. And I hover around this, you can see that it is now it's even too small. So I'm going to change it to 50 so that we don't have any issue. I don't want it to take time to generate. Click enter. You can see that our circle has reduced. So I will right click on that mesh and say generate. Okay, you can see we now have a more refined mesh. Okay, so I don't know, I'm seeing some questions on the chat box, but before I go, let me explain something probably to answer some of that question. You might be wondering, what is this mesh that you have to generate? Because it's very, very important. And if you want to do any analysis, you have to generate a mesh for that analysis. Okay, so what is mesh? All right, so mesh. Okay, so mesh is a discretization method that analysis softwares use to solve your engineering problems. Let's say, for instance, you're trying to do analysis on an automobile vehicle or a bike. Okay, you are trying to carry out an analysis on a motorcycle, or a bicycle, or a car, rather. You can see that an Ansys or any engineering software will want to calculate the values, the pressure value, the volumetry, any parameters you put, your boundary condition. It will want to calculate it on that body, but that bodies are irregular in shape. Okay, they don't have a definite shape. Okay, and they don't have any definite formula. For instance, your cube has a formula. The area of a circle is pi r square. The area of a cube is, I think, L square, right? Yes, L square. That's the area of a cube. This definite shape like circle, square, cube, cylinder, they have formulas for solving them. But irregular bodies like your motorcycle, those bodies are irregular. You cannot solve them. Human beings, our bodies are irregular. There's no formula to solve them. So what does this software do? So how can it solve these problems on these irregular bodies? What it will now do is that it will now, that irregular body now, it will now break it down. It will now divide it into definite shapes. Okay, you can divide it into square, or cube, because it knows that cube has a formula. So if you to divide your body, that let's say you want to solve an analysis on an automobile vehicle or a car, it will not divide that car body into smaller squares and into smaller cube and probably rectangle, parallelogram, smaller cube that have formula. So it will now solve the formula of each those individual cubes and add it together to give you the final result of that car body. So that's what it does. There's no formula for solving the shape or area of a plane. There's no definite formula for that. So what we the Ansys software do, or what will the engineering software do, it will divide that plain body into smaller definite shape that it knows that it can calculate for, or it knows that have a definite formula like square, cube, rectangle, polygon, all those smaller cube or hexagon, all those shapes that have formulas. It will divide it into smaller shapes that it can calculate. And when it is done dividing it into those shapes, it will not calculate for each individual element, which is those shapes that it divided it into. When it does calculating for each individual, it will not add it together to give it the area of that aeroplane that you're trying to find. So that's how this engineering software is function, especially Ansys. That's how it functions. That's what we mean by mesh discretization or by meshing. So it has to mesh before you solve any distance. That's why mesh is very, very important. Mesh is in fact the one of the most important things whenever you are doing any analysis. Okay, so I think our time is almost finished. Let me answer some questions, then we can go ahead and see if, okay, thank you very much, Sophia. Thank you, Ibrahim. I appreciate. Okay, they asked, someone asked, sorry, Favor, what's the course code? Ansys day one, that's the course code. Ansys day one, that's the course code. Then this person, Ayomide, asked, how did we arrive at the Ansys Mechanical? I explained at the beginning that whenever you double click on any finite element analysis, let me open up the slide again. Okay. Sorry about that. Let me open up the slide. Finite element analysis. These are examples of finite element analysis. Ayomide, hope you can see my screen. These are examples of finite element analysis. So whenever you open, if you open your workbench, you find out that some of these, if not some, all of these analyses are there. So anything you are working on this analysis, you double click or you are trying to open this analysis. Let's say static structural, dynamic, modal, thermal, non-linear, Buckler, explicit dynamics, and so on and so forth that are under finite element analysis. Ansys will open up Ansys Mechanical software for you because that is where you do most of them. Okay, if there is anyone that you don't do that, it will open it for you. Most of this analysis or most analysis that are under finite element analysis are being done using Ansys Mechanical. So if you should go for Ansys Workbench and try to open any, whether it's static structural or steady state thermal or whether steady state or transient, or you have your explicit dynamic here. Okay, you have your random vibration, response spectrum, all of the modal analysis, they are under finite element analysis. So anytime you open them, you try to open them by double clicking on this model, or you left click on the model and click on edit here. It will always open Ansys Mechanical for you. Okay, so that's how we arrived at that Ansys Mechanical. So let me see next if there's any other question. I believe that answers your question, Ayomide. Okay. Then Jonathan asked. Yes, Jonathan asked if I'm Mr. Henry. Yes, I said it at the beginning of the class. I don't know, I introduced myself. My name is Ugu Henry Christopher. I'm Mr. Henry. Yes, I'm the Mr. Henry. So if you have any in the group, when you are submitting your assignment or you have any question relating to Ansys, you can ask me. You are very free to ask me and tag my name, or you can tag me, my contact there. You will see my name there. You can tag me so that I can trace your question easily. So you can always ask me question. I'm the Mr. Henry. Yes, you're welcome. So our time, I think we are past 1 hour. So, okay, let me close here. All right, let's close here. Since there will be no assignment for today, so tomorrow we will continue from where we stopped. Okay, so tomorrow we'll continue from here. So tomorrow we'll continue from here. So if you have any question, you can unmute your mic and ask. I didn't want us to spend more than 1 hour. Okay, because the class is being recorded, so that whenever you are going back to go through the session, it will be easier for you, not get exhausted. So I don't want to give you all the knowledge in one section. You might even end up being confused, and. So I want it to be very easy and understanding. So I'll be giving it to you step by step. So today we've done everything, the overview, understand the basics of Ansys and how it functions. Tomorrow we'll go deep into the Ansys Mechanica and how to use the Ansys Mechanica to carry out the finite element analysis. Probably in the third day we'll go deep into, we'll talk about structural proper structural analysis on a beam structure. Or if we have time, we'll do thermal analysis too. Okay. So is there any other question? So if there is no question, I think we'll end the class. Okay. If you have any question, please, you can unmute your mic. Hope you guys have all filled the attendance. Please, the attendance will stop immediately we end the class. So please make sure you fill the attendance. The moment I end the class, we'll stop, the attendance ends. Okay. I think that's all. So thank you very much for making our time to be in today's class. I know this class was supposed to hold yesterday, so but I was not available. So I apologize for that. Probably by God's grace, it will not happen again. So tomorrow we will continue with our timetable. Tomorrow is Wednesday, which will be the second class. So tomorrow we'll continue from where we stop. Then on Friday we'll round up. Okay, so I think that will be all for today. So thank you for making our time to be in class. I really appreciate you, and good night. So have a good night rest. I thank you, everyone.